Now for a change of topic. I have some more code here, and this is another game of can you guess what the output from this program will be? I instantiate a string called apple1 which contains the word apple, and I instantiate another string called apple2. This is formed from the concatenation of two strings, but you can see the result should also be the word apple. And then I write out the two strings to the console, as well as the result from comparing them, first with the equality operator and then using reference equals. What do you think will be displayed? Take a moment to think about it before I run the program. Okay, let's try it. We have true and true. Based on what I've said so far in this course, that seems surprising. We would certainly expect the first line output to be true because the equals operator compares string values, and it's clear that these two strings will have the same value. But the second line appears to be claiming that the strings don't merely have the same value, but the two variables refer to the very same memory location. How can that be? Well, what's going on is that the C# compiler can be quite intelligent at times, and it can see at compile time that the string app and the string pull together make up the string apple. So rather than creating code to concatenate the two strings at runtime, it does the concatenation for you at compile time, and so emits code in which both apple and apple2 contain the hard-coded string apple. And you can probably see that since strings are immutable, a possible optimization of this code is, rather than hard-coding this string apple twice in the emitted assembly, to only have one copy of the string and have both variables refer to that copy. And it's fairly obvious from the results of running this code that it has been optimized in this way. So this is something you need to be aware of. If you have hard-coded strings in your code whose values are therefore known at compile time, then you may find they get compiled into one single string. That means that calling reference equals may return true for them, even if they look like different instances of the same string in your source code. This optimization not only saves memory, but can make string comparisons quicker, since if you are testing two strings for equality and they are the same instance, then you know straight away that they are equal without needing to examine any characters in them. On the other hand, if you have different instances of the same string, then the only way you can tell they are equal is by examining every character in each one. This optimization is, by the way, known as string pooling. Now in this code, I'll replace the apple2 declaration by calling copy on apple1. Now the copy method is guaranteed to create a copy of the string rather than sharing the instance. And if I run the code now, you can see that reference equals returns false. And by the way, that is the reason why in some of the demos earlier in this course, when I needed two identical strings, I generally called string.copy to get the second instance. Doing that avoided bringing in string pooling, which would have been very confusing when I was trying to explain the difference between reference and value equality. I'll also mention that you can, if you want, deliberately make strings share an instance at runtime, even if the values are not known at compile time. If I type string dot and I, IntelliSense shows me a static method called intern. You can use this to obtain a shared instance of a string. I won't go into that here, as in practice it's not often very useful, but it can improve performance occasionally if you need to do, say, lots of comparisons on the same strings. So if you're in that situation, the intern method may be worth looking up.